Doing all right. I got to admit, I'm a little disappointed. Uh, I just watched some news reports on the Mueller report, and I have to say, I'm very, very surprised at the findings of it. Probably even more surprised that Mueller was not willing to state definitively yes or no if Trump obstructed justice. He left it up to Barr, the gentleman who originally wrote a 19-page paper to get the job, saying how it was unlawful to go after the president like this. So, very surprised. I mean, I didn't see it coming. A rich white man got away with it. So, what are you going to do? But, I mean, it is what it is. Uh, I'm just now looking forward more than ever to November of 2020. Hopefully, we can end this very quickly. But anyways, I mean, other than that, on a personal note, I mean, I'm doing all right. Just kind of down about the world. I look outside and it seems all gray and cloudy. Anyways, it kind of is out there now. But anyways, let's see. What are we going to do today? We're going to wrap up the 2D geometry. I wanted to go ahead and at least start the 3D geometry, and then I wanted to give you some time in class to work on the assignment, like I told you on Friday. We'll continue to move forward. What's happening Thursday? Test is going to be on Thursday, but it's over right triangle trig, law of sines, law of cosines. I'll probably at some point give you maybe an exit ticket or quiz over the right triangle trig, but it definitely won't be showing up on this test. And then pretty quick, as soon as we're done with 3D geometry, we can get into limits and calculus. And then we'll go from there.
What sheet is that?
That one, that is this one right here. Mm-hmm. All right, there we go. Okay. That's the homework for law of science. Okay, so remind me, I don't remember how far we got on Friday, because those are blank and those are blank. So we finished 7A. Not this paper. Where am I? Wait a minute. Oh, there we go. That was the assignment. I was like, okay, that's why it's all blank. Okay. So we only had two left, 7B and 7C. And then we'll go straight into 3D geometry, and we'll see where we stand. Okay. So just like on Friday, we're finding the area of the shaded regions. Okay, so let's go ahead and take a look at this one together. So if I want the shaded region, I've got to find the area of two shapes and then just do what? Just go ahead and subtract them. There you go. I'm going to take the area of the rectangle minus the area of, looks like an oval, but I'm going to go ahead and believe that it's a circle. So let's say for the rectangle, okay, the area is, well, it's just always length times width, correct? So we have 12.8 times 8.3. 12.8 times 8.3. Whoop, that's a 9. 8.3. Okay. So I'm getting 106.24. Okay. So 106.24, and we're in centimeters. Square centimeters. Okay, so what's the area of a circle? Pi r squared. Okay, so for the circle, the area is pi. Now we have the diameter, so the radius would be 3.1. There we go. 3.1 squared. Let's see what we end up with here. So pi down here at the bottom times 3.1. Whoop, that's it. There we go. 0.1 squared. Okay. So 30.1907 square centimeters. So let's say 30.2. Okay. 30.2 square centimeters. And Eli's absolutely right. We just need to subtract the 2, and we'll have the area of the shaded region. Looks like a frame almost. Okay, so I'm going to take the rectangle minus that. Okay, so I'm getting about 76.05. Okay. So 76.05 square centimeters. There we go. All right. And we were talking about perimeter and all kinds of other good ideas on Friday when we did this. In fact, we almost got done with it. So who would like to come on up and show me C now? So many hands. I just need one. Okay, then let's see here. It goes through. Okay, so it goes. Okay. Okay, 1, 2, 24, 19. So I believe that's Camille. All right. And I think Camille was just about to say, I'll go ahead and do it anyways. There you go. All right. So let me erase this for you right here. Okay. So we want the darkened area. So 15 times 6 divided by 2. Yeah, so, or I can type it in, or somebody can help you out. Basically, 15 times 8. Okay. So 120.
Is that divided by 2 or?
Yeah. Mm-hmm.
No.
Okay, so that's 120 square centimeters for the whole thing. Okay, the largest triangle. Now for the other ones, the base and the height, 7.5 times 8 divided by 2. So 7.5 times 4, 30.
So then divided by 2 is 15.
Oh, no, we already divided by 2. There you go. .90 square centimeters. What do you guys think? Beautiful? That's what you got? Nice. Okay. All right, so those other problems that we were looking at the beginning, that's actually on assignment that I'm going to go ahead and give you in just a few moments. Now, I say a few moments because I did want to go ahead and at least start this right here. And I'm hoping that, definitely by tomorrow through the end of the week, we should be able to pretty much wrap this up. Because in the next coming weeks, we're going to have several days where we're going to be losing those days. In fact, what's happening the first week of the last 6 weeks? Star. English 1 and English 2, so those are going to be late start days. So one day I may not even see you. Another day it might be for like a good 30 minutes, if that. So, we have so much days left of school, but we have a decent amount of material to do because I want to review you and actually go through a real test. Hey, those are late start days, yes, the STAR exams. So if you're already done with that, you don't need to take it. I think it's 1:30 you show up. Is that right? 1:15 or 1:30?
I think 1:30.
It's somewhere around there. Yes, ma'am.
Is that April 1st, which is the week after?
That is the week after. Because this coming Monday is April 1st. This coming Monday is April 1st. And April 5th, not only is the end of the 6 weeks, but it's also Shazam. So go see it.
It's not already.
No, it opens next week.
Oh, I thought like someone already like watched it.
No, the 5th is Friday. No, 5th.
It's not like.
Well, and then they do the advanced screenings on the 4th.
Oh,
You know.
yeah.
Okay. All right. But if we don't support DC, Marvel wins. Kidding. I like Marvel.
I
Like
like
Marvel. I've always thought the DC movies were good. There are problems with them. There are things I wish they had done differently, but I don't think they're as horrible as people say they are. Aquaman was good. I'm really looking forward to, because they've never done Billy Batson before. That's a character that hasn't been given his own live action version. Yeah, so and I like Zachary Levi. Is it Levi or Levi? I liked him ever since I watched Chuck, so that was a good show. That was a good show. Okay. All right, but back to this. Let's go ahead and at least get one problem done. We're looking at a rectangular prism, and then I'll pass out your homework, and we'll go from there. Okay, so the rectangular prism, side lengths and diagonals are marked. Note, diagrams are not drawn to scale. So you can tell, yes, very, very clear in the picture here. So we know that AC is 10. Okay. CH is 10. We already have that listed. EH right here is going to be 8. So that would be 8 right there. And then AE is equal to 8. Okay, so that's listed. Now, because this is a rectangular prism, remember we named the prisms based off the fact that the bases are the shape we use. So do we know the height? Like, for example, AB.
No.
No, don't know that yet?
Wait.
Or do we?
Is it just 8?
Well, would it be 8? Now, is a rectangle, or excuse me, is a square a rectangle?
Yes.
It is. So a square is a rectangle, but is a rectangle a square? No. Okay. So let's go with what we know so far. It says calculate the length of AH. And what I like to do in these is I like to go ahead and use different colors to help me visualize what's happening here. So I want this diagonal AH. Well, the top face here, that is a rectangle. And we know that E is going to be a right angle. So we could go ahead and use that to help me figure out what AH is. Would everybody agree? Okay. In fact, let me go ahead and draw it here. That's also another thing I like to do. So this would be AEH, and that's D, I'm sorry, right there. And then we're looking for this. So we know that's a right angle. We know AE was 8, and we know that EH was 8 as well. Okay. And what theorem is going to be able to help me do this? Pythagorean. Okay, so let's say, let's just call it X. So what would the Pythagorean expression be that I'm going to write here? 8 squared plus 8 squared is equal to X squared. Okay, so 8 squared is 64, so 64 plus 64.
Wait, Mr.
Wait, did I make a mistake?
No, you didn't make a mistake, but isn't the fact that AE being 8 and EH being 8, doesn't that mean that this is a cube?
Yes. So in fact, if you know your special right triangles, you could just go ahead and say 8 square root of 2. Is that what you were going with?
Well, is it just 10 centimeters? Because
Would not be 10. If we're going to take the shortcut, it'd be 8 square root of 2.
Vertical is. We don't know what the vertical is.
Mhm.
Okay, continue.
Okay. Now let's go ahead and run through. That's good that you noticed that. It is going to be 8 square root of 2, but I'm also wanting you to see that even if you don't realize it's a special right triangle, you're still going to end up with the same thing, because 64 plus 64 is 128, and how do I get X from X squared? Okay, there we go. Now, see, here's the thing. We could go with a decimal on this, but since a lot of times these problems are going to be very progressive, we're probably going to use this to help me with something else in the problem. So we won't go with a decimal just yet. But the square root of 128 can be rewritten as 64 times 2, 64 being the largest perfect square that will evenly divide it. So that's where we're getting 8 square root of 2. And of course, the other special right triangle would be a 30, 60, 90. This is a 45, 45, 90, okay, because it is a square. Okay, good. So any questions on A? Now we got the diagonal. Okay. Find the size of angle ACH. Okay. So ACH right here. So this angle. All right. Now, because C is the middle, that means it's the vertex we're looking for. So let me go ahead and sketch this again. We know, given this triangle, and kind of imagine this triangle like if you had a stack of paper, this would be one piece of paper right in the middle of it, just one slice contained within the pyramid, or I almost said pyramid, this prism. So this is A, this is C, and this would be H right here. So we know that AC is 10. We know that CH is 10, and we just found AH to be 8 square root of 2. And we're looking for this angle right here. Everybody agree? And that's something that I would encourage you to do. It's something that's helped me out a lot, because for a lot of people, these three-dimensional objects, sometimes it's very hard to visualize those in your mind's eye. So every time you can draw maybe a little portion of it to the side just to help you see what's going on, okay, we can absolutely do that. So how am I going to find ACH? Is there something that we talked about recently? Law of cosines. Here we go. Law of cosines, because I do have a triangle where I know all three sides, right? Is everybody good? Okay, so if I'm trying to find angle C, basically, how will I start my equation? What side length would I use? There we go, the one directly opposite that. So 8 square root of 2 squared. Or, I mean, you could just go ahead and put the 128 and get you right back to the radicand we had a moment ago. Equals. Now, what do I do with the other two side lengths? Okay, we square them and then we add them. So I'm just going to go ahead and say 100 plus 100 because the other two sides are 10. I'm sorry? Did I make a mistake? Oh. Okay. Now what? Well, I mean, it's, it never happens that I make a mistake, so it's, a little too quiet when I said that. It's minus 2. We always subtract 2 times what? Times 100. We multiply the two sides. So 2 times 100, and then cosine of theta. Okay. So we actually probably could go ahead and take care of a lot of this. We could go ahead and type in, well, 8 squared root of 2 squared. Remember I said that was 128 minus 200 divided by negative 200 should give me cosine of theta. Is everybody okay with what I've done so far? I just kind of simplified as I went through. Now, if I'm looking for the angle and I have the ratio, I have to do what? Take the inverse. So I need the cosine inverse of this. And we could probably even simplify it a little further. What's a 128 minus 200? There we go. So we could say cosine inverse, control divide. And we know the two negatives are going to make a positive, but why not? Negative 72 over the negative 200. Okay. So what should I be getting when I push enter? Okay. Gabby, you said what? I'd say 68.899. So we could probably make an argument for 69 degrees. Okay. But I think I'll go ahead and round it to 1 decimal place, give 3 sig figs. So 68.9 degrees.
So,
Yes.
I have a question. So, why
What was
wouldn't we just be adding angles DCH and ACT together?
Okay, so DCH
Yeah.
and angles what?
ACD.
Oh, because see, those angles are on the face. So this angle, imagine it's kind of tilted going straight through. So it's below this corner right here, this triangle that I drew. It's like going straight through the middle of the prism.
Okay, so
Does that kind of help?
the points in the center of the prism?
Yeah, so it's rotated down from this vertical edge right here, from this guy. Because the two angles you were talking about, like for example, ACD, that's directly on the face, and DCH, that's directly on the face as well. But this one, because the third side of the triangle is the diagonal, I'm sorry?
So like the bottom face?
Not the bottom face.
I'm having a lot of issues.
Yeah, let's see. Is there any other way anybody thinks they know I can help him visualize this? Because I don't have any actual prisms I can show him. Maybe... Okay, well, I got this. Okay, so imagine you've got... Okay, so what you're talking about here, like for example, let's say this represents the prism. So this is ACD. So the way you said it, ACD, you're talking about this angle right here that's actually on the face. The same thing for over here, this angle. But we're using, imagine that this is the corner of that one triangle that I have right there, that's C. This is A, but I'm wanting to make a two-dimensional triangle with this other vertex right here. So imagine it's cutting through like that. See, that's why it's right through the center of it. Does that kind of help?
Yeah, that makes sense.
Yeah, so use the example that I had a little while ago. Like imagine you've got a stack of paper, but you're thinking about one individual piece of paper right in the middle of it. And of course, this isn't a stack of paper, but it might help you visualize that one little slice that we're looking at. Does that kind of help?
Yeah, that makes sense.
Okay. Emily, that helps too? Okay. Is anybody else having a hard time visualizing that? Okay. All right. Let's see what else we got here. Two more, and then we are done for this lesson so far. Find the total surface area of the rectangular prism. Okay. Well, it's a rectangular prism, so think of it as a room, like a three-dimensional room. Okay. This front face here, ABCD, is going to have the same area as what? EHFG. There you go. Okay, so what we can do is just go ahead and say like the front. I'll go ahead and call them the front. Okay, then we'll call it the top and the bottom. And then we'll go ahead and say the sides, left and right. Okay. So the front, it's going to be what? We know that this right here is, this is 8. I erased it, unfortunately. Okay. Now this right here, you remember how I was saying, could we go ahead and say that AB was 8 as well? We actually cannot. In fact, what's the height of this? Do you recognize what kind of triangle that is? It's a Pythagorean triple. It's a 3, 4, 5 that's been doubled. So the height is actually 6. Okay. Does that make sense? Okay. I'm looking at this triangle right here. All right. That's how I was able to get the height. If the hypotenuse is 10, I know that the base edge is 8. That has to be a 3, 4, 5 or a 6, 8, 10. I just doubled those. In fact, there's a lot of different Pythagorean triples out there. Another common one is 5, 12, 13. 5, 12, 13. Okay. Or any multiples of those. So let's see. How would I find the area of this front face? Yeah. So 6 times 8, and then I'm going to double that. Because remember, we have 2 faces. So that's going to be 96. Okay. Then the top, okay, we actually said those are squares. So that's going to be 8 times 8. But again, we've got 2. The top, like the ceiling and the floor. Okay. So basically 64 times 2, we actually saw that. 128. And the last one here, the left and the right. So we know this is 6. We know this is 8 again. So again, we're going to be doubling 6 times 8. Okay, which is going to give me another 96. So if I add all those up, what do I get? Okay, 320. Would everybody agree? 320, and we're dealing in centimeters. There we go. Questions? You guys remember the fun you had in geometry a long time ago? Yeah? Okay. All right. Last one. A triangular prism is enclosed within the planes ABCD. So let's take a look at this. Okay. So triangular prism, ABCD. Okay, so we're going to be using this front right here. Let me go ahead and take this off. We know that was 8, 6, 6. Okay. So ABCD, CGHD. So CGHD. And then ABGH. ABGH. Okay. So we are cutting this guy straight down the middle. Okay. What we want to do is calculate the volume of this prism, that triangular prism. That's exactly right. Because, I mean, think about it in a simple two-dimensional case. If you had a parallelogram, it's always base times height. But a parallelogram is actually 2 right triangles. So that's where you get the formula half the base times the height. Okay, so the same thing applies to the prism here. So how do you find the volume of a three-dimensional figure? Okay, so base times width times height. So I'm looking at 8 times 8 times 6. Okay. And then if we only want the triangular prism, we're going to go ahead and divide that by 2. So what do I get? 192 centimeters cubed. There we go. Now we're talking in 3 dimensions, so our measurement is cubic. 2-dimensional is the square. All right, very good. Very good. All right, questions. Okay, then let me go ahead and stop right there.